Dear student, myself Rajendra Aaseri, I am Assistant Professor in Computer Science Department at Government Bangalore PG College, Didwana. In the previous lecture, we started a lecture series on database and management system, and in that lecture series, we discussed various concepts on SQL, that is structured query language, relational algebra. In relational algebra, select, project, division, union, intersection, set difference, aggregate function like sum, average, minimum, maximum, count, all these we have already discussed, right? Then we started a new lecture series on the physical storage media. In that we discussed up to this point are the memory hierarchy, various type of data storage devices like cache memory, main memory, magnetic disk, op, optical disk. Okay, all these we have already done. And then we discussed various comparative parameter like speed and cost parameter of these memory storage devices, right? Now, in the just previous lecture, we discussed about various performance measures of a disk, hard disk, like access time. In access time, there were seek time and rotational latency, and data transfer rate, and various type of algorithm of disk arm scheduling. Like the most popular is elevator algorithm, which we already discussed. Now, in today's lecture, we are discussing about the new technique of data storage, that is RAID, and RAID stand for redundant array of independent disk. So starting with RAID stand for redundant arrays of independent disk. Okay. Now, as the name implies, in common term we can say, if we are having a redundant information, then we can store these information in some separate disk, and all the disks are independent to each other, right? Now, in going in the technical detail, the first point, disk organization technique that manage a large number of disks, providing a view of a single disk of high capacity and high speed. It is very important that are used for high capacity, to store the high capacity of the data, and high speed, maintaining the high speed of the processing by using multiple disks in parallel. Very, very important point. In RAD, multiple disks are used, but they are used in parallel manner. The processing will be done in parallel manner. That's why they are maintaining the high speed, and high capacity is also supported. Now, high reliability by storing data redundantly. High reliability means there is less chance of data destruction, right? So high reliability by storing data redundantly, so that data can be recovered even if the disk fails. That's why here we are storing the data in redundant form. So at least at one place, if the data is destroyed or lost, then it will be available in some other disk. Now, the chance that some disk out of a set of n disk will fail is much higher than the chance that a specific single disk will fail. There is a chance of failure is higher, okay, but the some disks will not be affected. That's why the data will be available in that particular corresponding disk, right? Example: a system with 100 disks, each with mean time and transfer time failure of 1 lakh hours, approximately 11 years. 1 lakh hours means 11 years, will have a system mttf of 1000 hours, approximately 41 days. Very important. Now, techniques for using redundancy to avoid data loss are critical with large number of disks. Very important. Means the techniques which we are using for the redundancy to avoid the data loss are very, very critical with large number of disks. Now, originally a cost effective alternative to large expensive disk, this is an alternative. Suppose in red originally stood for inexpensive. I in the red originally stand for what? Inexpensive. Generally we are saying that it is for independent disk, but I generally stand for inexpensive, right? Now, today RAIDs are used for their higher reliability and bandwidth. The I is interpreted as now independent, right? So it is used for now improvement of reliability via redundancy. Means if we want to improve the reliability with the help of the we can say redundancy inclusion, then we can do in this RAID. How? So first you need to understand redundancy. Redundancy means storing the extra information that can be used to rebuild information lost in a disk failure. Means suppose while processing with the disk, if the disk is lost, then the corresponding information is also lost. So if we are storing the information at some extra places, then it is called as redundancy. Okay. Example, mirroring or shadowing. What happened in mirroring? In mirroring we duplicate every disk. Now logical disk consists of two physical disks. Every write carried out on both the disks. There are two disks, one is duplicate and one is the original. And what we do, every write is carried out on both the disks. Okay. Now reads can take place from either disk. Okay, write will be done on the both the disk, but read can be take place from any of the disk. If one disk in a pair fails, then data is still available in the other. That so in this manner we can ensure the reliability, right, with help of redundancy. Now data loss would occur only if a disk fails and its mirror disk also fails before the system is repaired. Okay, then only data loss will be happened. Now probability of combined event is very small. Means there is a very rare probability that both the disk original disk and its mirror disk will be failed at the same time. Now except for dependent failures modes such as fire or building collapse or electrical power surges, in that case all the mirror disk as well as the original disk will be destroyed. Okay. Now mean time to data loss, very important point. Mean time to data loss depends on mean time to failure and mean time to repair. Example, mean time to failure of 1 lakh hours, mean time to repair of 10 hours gives mean time to data loss of 500 into 10 for 6 hours, that is 57,000 years for a mirrored pair of disks, ignoring dependent failure mode, right? If we are ignoring the dependent failure mode, then it will take approx 57,000 years, okay, in order to destroy both the mirror disk as well as original disk. Next is improvement in performance via parallelism. First point was improvement in the reliability with help of redundancy. Now we are improving the performance with help of parallelism. So if you notice, initially I said that in red all the disks are processed or are doing their task in the parallel manner, right? So improving the performance or speed. Now two main goals of a parallelism in a disk system are load balance, means multiple small axes to increase the throughput. Now it parallelize large accesses to reduce the response time. Okay. Now it will improve the transfer rate by stripping data across multiple disks. Clear? Now bit level stripping. Before bit level stripping, this point is very important. It improves the transfer rate by stripping data across multiple disks. Now next is bit level stripping. In bit level stripping, we split the bits of each byte across multiple disks. Okay, splitting the bits across all the multiple disks. In an array of 8 disks, write bit I of each byte to disk I. Okay, I bit corresponding to disk I. Similarly, the next position bit will go to their corresponding disk. each axis can read data at 8 times the rate of a single disk. Yes, because there are 8 disks suppose, so the speed will go to the 8 time, right? Because they all are performing in parallel manner. Now, but seek or access time is worse than for a single disk. Okay, bit level stripping is not used much anymore. Nowadays, bit level stripping is not used. Next is block level stripping. In block level stripping, what happen with n disk, block I of a file goes to disk I plus I mod n plus 1. I mod n plus 1, suppose I value is 7, n value is 10, so 7 mod 10, the result will be 7. Plus 1 means 8th. At 8th number, it will go to, suppose there are n disks, then ith block will go to the 8th number. Now, request for different blocks can run in parallel if the blocks reside on different disk, right? Next is there are various RAID level available. In RAID, redundant area of independent disk, there are various levels available, and every level is having some significant significance as well as their corresponding features. And according to requirement, we can pick any level. Okay, so schemes to provide redundancy at lower cost by using disk stripping combined with parity bit. Parity bit is included in order to reduce the cost and by for including the redundancy. Now, different RAID organizations or RAID levels have different cost, performance, and reliability characteristics. Suppose first is RAID level 0. Now, RAID level 0 is used for block stripping and it is non-redundant. It is generally used in high performance applications where data loss is not critical. So where high performance is required and data loss is not a critical point, then there we can impose the RAID level 0. Next is RAID level 1. It is having a feature of mirrored disk with block stripping, right? It offers best write performance. It is popular for applications such as storing log files in a database system. So if we want to store the log files, then we should go for the RAID level 0. And if we want high performance application where data loss is not critical, then RAID level 0 is the advisable, right? So if you see the diagram, RAID 0 is non-redundant, is using the non-redundant stripping, okay, and RAID 1 is using the mirror disk. So if you see, 4 disks are the original disk and 4 disks are the mirror disk. These are the mirror disk and these are the original disk, right? And in the upper, all are non-redundant. Non-redundant means there is no duplicacy, and all are the independent disk, right? Now next is RAID level 2. RAID level 2 is based on the concept of ECC. ECC means error correcting code for memory style, and it is used with the bit stripping. Generally bit stripping is not used, but in level 2 we are still using bit stripping. So if you see level 2 diagram, so all are the some are the original disk and some are the mirror disk. In RAID 2 memory style error correcting code we are used to imposed with bit level stripping, right? Next is level 3. It is bit interleaved parity. It uses a concept of bit interleaved parity. What is that? A single parity bit is enough for error correction, not just detection, since we know which disk has failed. If you know the which disk has failed, then a single parity bit is enough for error correction, and all are the other original disk. When writing data corresponding to a parity bit must also be computed and returned to a parity bit disk. To recover data in a damaged disk, computer XOR of bits from other disk, including parity bit disk. Clear? Next is RAID level 3. Continue. It is faster data used for faster data transfer than with a single disk, but fewer input output operations per second, since every disk has to participate in every input output. That's why input output speed will be slow. If assume level 2, Okay, because it provides all its benefits at lower cost, so it is better than the level 2 RAID. Level 4 RAID, it is based on block interleaved parity concept, and it uses block level stripping and keeps a parity block on a separate disk for corresponding block of another disk. So when writing data block corresponding block of parity bits must also be computed and written to parity disk. So see, one parity bit is in and other are all the original, and it is based on the block interleaved parity. To find value of a damaged block, we have to compute XOR of bits from corresponding blocks, including the parity block from other disk, right? Now in level 4, it provide higher input output rate for independent block than the level 3. It provide higher transfer rate for read of multiple block than no stripping. Before writing a block, parity data must be computed. And how to compute the parity data? 2 block reads plus 2 block write. In this manner, we need to compute the parity block. Right? Parity block become a bottleneck for independent block writes, since every block write also write to a parity disk. Very important. Means parity blocks can sometimes be the drawback for independent block. Why? Because it writes, since every block write also writes to the parity disk. So that's all from this lecture. In next lecture, some new concept on the physical storage media. Thank you.